Hello, in this video we will demonstrate how to complete an offline change or modification with allowed application mismatch on an M580 Hot Standby non-safety system. So that means that we're going to be able to do an offline change without taking the whole system down and keep at least one CPU always in charge of running the process and the IOs. As mentioned, this is valid for this procedure is valid for a non-safety system. This is also for this procedure to work, you need to be using Unity Pro V12 or greater. So that means all Control Expert versions are going to be working, and the firmware of the CPU must also be version 2.80 or greater. So on both of the M580 CPUs. So the procedure that we're going to follow can be found in the help file. Here, let me bring that up. In M580 Platform, configuring, working, and offline. So this is the procedure we're going to be following here today. So there's a few settings that must have been defined or set in the system for this to work. So let's take a look at those in the Hot Standby. So we need to have either first section or all sections for this settings, and the Allowed Application Mismatch is not mandatory but highly recommended, as sometimes it might not work if this is not set. So let's connect back. So right now we have a fully functioning system. The CPU Bs run primary, the As run standby, and they are both equal. So everything's good, the system is running. So in the first step, we need to add a block that's going to allow this offline change to be made. It's called the HSBY build offline. In my case, we see that only the first section is being executed by both the primary and standby. So we're going to go to my first section. Let's go grab that block. So this is an online change, so that you should be able to do this without having to stop the process or anything. So here I'm just going to plop in some variables there. Go. I'm going to build those change. I'm just going to make everything equal again. All right, so that's the first step. So we've added this block here. So this is an online change. So this is step one. So just add that block in a section that is both executed by the primary and the standby. In my case, only the first section. So that's why we are in the section that is called first, which is my first section, as you can see here. All right, so now we need to connect to the primary CPU, which I'm already are, so that's good. Now we need to set that bit to 1. So let's create an animation table. So now this bit has been set to 1. Next, we need to confirm that the logic mismatch is allowed. It should be because I was able to do an online change without any problems, but let's verify to make sure. So we're going to go to my variables. We're going to grab the Hot Standby variable here, expand that, and this here that one, the logic mismatch allowed, is the one that you want to have to 1. If for some reason it's 0, just write a 1 in there, and that will probably do it. But if you follow the mandatory settings, this should already be at 1. So now the next step is to actually disconnect from the primary CPU. And we're going to do a change for this example. The change we're going to do is add a Modbus device in the DTM browser. So let's go here, add Modbus TCP, add a Modbus device. I'm going to confirm, and let's just call it new Modbus device. Here we go. So very important here is that you want to do change that are going to be able to do by doing a build change, and you never want to do a rebuild all project. This will most likely make this whole procedure fail, and you'll have to upload back from the primary, transfer to the standby to get an equal system again. So the only offline changes that are going to work with this procedure are the ones that are able to be done or to be built using the build changes command. So in this case, adding a Modbus device, that's something that's allowed. So so I've just added the new Modbus device, and then I'm going to go ahead and proceed with the build and the build change. So we're back in the build state. Next step is to connect to the standby CPU. So in my case, the standby CPU is going to be at the following address here. Okay, and so we see here now by the first thing here that I'm connected to the run standby, and of course I'm different because I did an offline change. I'm gonna now download into the standby system, or should I say the standby CPU. Do the transfer. All right, so that's completed. So now this one's in stop, so I'm just gonna go and put it into run. So we wanted to switch from stop to being in wait. Okay, so when this is done, this step is a success. So now the next step is on the standby, which is the one we're connected right now still. We need to also set that offline allowed block. So let's do a new animation table. And do this. So now this is also allowed. Okay. Before we end that step, just verify again that we do have still a running standby and a run primary system, which is what we have here. We now need to issue a swap command. So the standby, which has the new version of the program, needs to become the primary, and then the CPU that's primary needs to be switched off over to the standby role. So I'm going to use the hot standby. Sorry about that. I'm going to use the command here. So let's go PLC bus here, and then animation, and do a swap here. Now, in some occasion, this might disconnect you depending on how you were connecting, either USB or Ethernet. In my case, this is good. This is going to disconnect me, and I'm just going to reconnect in a few moments. Okay, I'm back. So now we see that A is now the run primary and B is in the standby role. So the swap did actually occur. So from here, all we need to do is force or issue a command to transfer the project from the primary to the standby. So for this step, we're going to use the variable here. So there's different ways. You can use the menus, or you can use like the animation here to force a transfer. But in my case, I'm going to use like the variable here. So we're going to go and command an app transfer. Okay, so now and then the net. And then right now it's in stop, and we're just going to say run the remote. So now we've completed the procedure, or almost completed the procedure. We see that now the system is fully back online with a run primary and a run standby. They're all equal, and at all times, one or the other PLC was actually controlling the I/O, so the process never went down. The procedure recommends that the last step is to come back here and just reset the value of the offline block on both the primary and the standby. So I've done it on the primary here. I can quickly disconnect and just quickly connect over to the standby to make sure. All right, so in the process of doing the transfer, it was already reset back to 0. So that actually completes the whole procedure. Hopefully that will help you complete some offline modification, which are able to be built using the build change option. So thank you for watching.